everyone, we're going to solve trig equations that are quadratic in form. This means that it involves factoring. So on this first one, we notice that this isn't a trinomial, but what we can do is factor out a cosine, because they both have cosine. So I'm going to factor out a cosine of theta, and I'm going to get 2 cosine of theta plus 1 equals 0. So I'm going to separate this out and set cosine of theta equals 0, or 2 cosine of theta plus 1 equals 0, and then just solve from there. We already know from this one that cosine of theta is 0 at pi over 2 and 3 pi over 2. Now on this side, I'm going to have to subtract the 1, then divide by 2. And we know that cosine of theta is the angle where cosine of theta is negative 1/2 is 2 pi over 3 and 4 pi over 3. So my solution set is pi over 2, 3 pi over 2, 2 pi over 3, and 4 pi over 3. And it's basically just like you would do quadratic form, your quadratics. Alright, now this one, we've already done one like this in a previous video, but we just added 1 and square root at both sides. This time I'm going to do it a little different, and I'm just going to treat this as a squared minus b squared, which we know is sine of theta minus 1 times sine of theta plus 1 equals to 0. It's just a different way to do it. And I'm going to do the same thing here. I have sine of theta minus 1 equals 0, and sine of theta plus 1 equals 0. It's actually or. So we have sine of theta equals 1, and sine of theta equals negative 1. Well, in this case, my angle would be 3 pi over 2, and in this case, my angle would be pi over 2. So my solution set is pi over 2 and 3 pi over 2. Okay, the next one is one we're going to have to factor. It is a trinomial. So this would be like saying 2x squared minus x minus 1 equals 0. And so you're just factoring it like that. And what we're going to get is 2 sine of theta plus 1 times sine of theta minus 1 equals 0. Now break this up, and we have 2 sine of theta plus 1 equals 0, or sine of theta minus 1 equals 0. Now, hopefully by this time, I'm going to subtract the 1 and then divide by 2. So we get sine of theta equals negative 1/2, and this one is sine of theta equals positive 1. So theta on this side would be 7 pi over 6 and 11 pi over 6. And on this side, theta would be pi over 2. So my solution set is 7 pi over 6, 11 pi over 6, and pi over 2. All right, here's another one, same thing. So just factor that, and we get cosine of theta plus 1 times 2 cosine of theta minus 1 equals 0. And kind of, this is your or part. So we have cosine of theta plus 1 equals 0, or 2 cosine of theta minus 1 equals 0. In this case, on the left, we have cosine of theta equals negative 1, and on the right, we have cosine of theta equals 1/2. I added the 1 and divided by 2. So here we have theta equals 3 pi over 2, On this side, we have theta equals pi over 2. My solution set, therefore, is pi over 2, comma 3 pi over 2. And we have one more. This one's already broken down for you. So, therefore, we are just going to write it as tan of theta minus 1 equals 0, or secant of theta minus 1 equals 0. We have on this side tan of theta equals 1. On the right, we have secant of theta equals 1. In this case, tan of theta equals 1 at pi over 4 and 5 pi over 4. That's quadrants 1 and 3. And secant of theta equals 1 where my angle is 0. Therefore, my solution set is pi over 4, 5 pi over 4, and 0. The next set is very similar, and this will be called part 2. Thank you. Have a nice day. Bye-bye.